Mm. Okay, so in the last session, we covered the basics of Kubernetes. Like as I said, Kubernetes is a vast topic. Okay, there is a special certification for Kubernetes, and it will take around 30-40 hours to cover the whole Kubernetes if you want to cover everything in detail. So in this basic course, we are going just with the basic of Kubernetes. Like most of the basic part I have already explained. For example, why do we need Kubernetes, and what was the issues with Docker container that Kubernetes is helping us with? Because with the Docker containers, with the Docker, we are only able to create containers, but we are not able to manage them properly. Okay, for that, for managing containers, for orchestrating containers, we have multiple tools available in the market. For example, Docker Swarm, Kubernetes, ECS. Okay, many tools are available in the market. But yeah, Kubernetes is the most popular one. So that's why we are studying Kubernetes. And Kubernetes is it is a container management tool, or you can say container orchestration tool. So whatever containers are created by Docker using Docker, so Kubernetes can manage all those containers. Okay, and we saw the architecture of Kubernetes. So we saw that Kubernetes works on master-slave concept. You have a master node, okay, and you have multiple slave nodes, okay, and you can have n number of n combination of master and nodes is called a cluster. Okay, in your cluster you can have one master and one node, one master and many nodes, many master and many nodes. You can have various types of combination. Okay, so combination of your master node and your nodes, all your worker nodes, is called a cluster. Okay, so it's very obvious that from master you will fire the commands, and those commands will get executed on the nodes. Okay, and yeah, coming into detail of the architecture, so we saw that Kubernetes has, in the master we have multiple components. We have a API server is like, it's like a heart of uh, uh, Kubernetes architecture, you can say. So all the communications are happening using API server. Even the user who fires the command using kubectl. Okay, kubectl is a tool using which the user interacts with the Kubernetes cluster. Okay, the user will fire the command using kubectl, and whatever commands he's firing will go to the API server first. Okay, and whatever communications are happening within the cluster is happening via API server only. Okay, then we saw etcd cluster. Etcd cluster is like a database. Okay, and it manages all the nodes. Like it contains details of everything about the cluster, like how many nodes are there, how many pods are running, like everything, all the details about the cluster this etcd cluster contains. Okay, this you can say is not an actual part of Kubernetes, but yeah, you can assume that it is a part of Kubernetes. Okay, because it contains all the details, but it does not come with a Kubernetes installation. Okay, so yeah, then you had control manager. Control manager is the component that keeps desired and actual state. It checks that the desired actual state is equal to desired state. Desired state is what the user desires. Okay, whatever configuration user wants to make, that is a desired state. And actual state is what is the configuration right now. Okay, control manager manages that it controls that uh, actual state is always equal to desired state. Okay, but it does not do the actual work. It is like a manager, he does not do the actual work. For doing the actual work, he connects with the kube scheduler. Okay, cube scheduler is intelligent, he's like an actual worker who does all the job, and the cube scheduler is actually uh, managing all the pod creation and like uh, where the pods will be created in which node. For example, you can have multiple nodes in the master. You can have multiple workers in the master connect in the cluster. So in which node the user wants to create the pod, Cube scheduler manages it, and how to create a pod. Everything, all the things, actual work is being done by the Cube scheduler. Okay, and we saw that in control manager also we can have multiple components. There is a volume manager, there is a manager that manages the IP in the network, there is a manager that manages the Like we saw many components, like deployment manager, which manages the versioning and the rollback. We have replication set, which manages the scaling and healing. Okay, which manage there is a manager that uh, uh, to manage like different things. We have so everything is, sorry, this was type of controller: node controller, root controller, service controller, and volume controller. Volume controller controls maintains the volume. Like we saw about Docker volumes, correct? What was the need of Docker volumes and everything we saw. So for if you want to share the data between multiple containers, you have the concept of volume. Okay, the same concept, all the concepts apply here as well, because these are also containers, right? And node controller, how they can be I told you, right, they can be multiple nodes inside a cluster. So how to control all the nodes. Root controller, how to manage the networking. Okay. Service controller is how to load balance between multiple nodes. Okay, so all these things your controller is managing, but the actual work we saw that is done by the kube scheduler only. Okay, this was on the master side. Okay, and on the worker side also, there are a few things you need to install. So first thing is kubelet. Okay, kubelet is like it's a very important component. It's one of the most important component for a no for a worker. So kubelet manages the pods. Okay, and about the pods, we saw that pods is a basic unit of Kubernetes cluster. Okay, that is a very basic unit of Kubernetes cluster. So a pod is a wrapper. Pod can be called as a wrapper of on a container. Okay, because Kubernetes does not know container. Kubernetes does not know container. Kubernetes knows pods. Okay, and pods is like a wrapper. So whatever communication is happening, it is happening via pods. Okay, kubelet will do actions on the pods. It will not do actions on the containers. Okay, so container in a pod, you can have multiple containers, but recommended way is to have only a single container inside a pod. Okay, and you can have multiple pods in a in a worker node. Okay, let's say in this example we have example of two worker nodes. In worker node 1 we have two pods. Okay, you see pod number 1 has two containers, pod number 2 has one container. Okay, and in worker B, in a worker node 2 we have three containers, three pods, and every pod is having one container each. Okay, and who is managing everything? It is managed by the kubelet. Okay, and container engine, we saw container engine, we already know Docker is one of the container engine. Okay, Docker is one of the container engine. So when we are doing the installation, we have to install Docker first, because the whole idea of Kubernetes is containers, right? Kubernetes containers, it's a container orchestration. So you have to have something which creates a container. Okay, so you have Docker for that. Okay, not only Docker, you can install different types of container engine, Docker, or you can install Rocket, or there are many types of container creation tools available in the market. So Docker is one of them. So we already studied Docker. Okay, then we have something called kubeproxy. Kubeproxy is responsible for handling all the networking related things, networking and the routes. So networking as in, so every pod will have a unique IP. Okay, every pod will have a unique IP because there are containers running inside the pod. Okay, there are containers running inside the pod, and every container might have different application. Every container might have different applications running. So how will the people from outside access the application running inside the container? Okay, it will be via the IP of the pod. Okay, so who gives the IP to all the pods? It's a kubeproxy who manages all the networking. Okay, so clear about the architecture, Prakash? So I gave you a brief overview of whatever we discussed on Kubernetes.
Yes.
Okay, so this is clear.
Yes.
Okay. Okay, so today we'll go into more detail. For example, we'll see how to install Kubernetes and all those stuff. Uh, so after installation of Kubernetes and all those things, uh, like the basic part will be done mostly. Okay, we'll see how a single node can be acted as a master, and we'll create two different other worker nodes as well. So if you fire some commands from the master node, it will be reflected on the worker nodes. Okay, how it is managed, we'll see that. Okay, so let's go with the demo. Basics are clear, right, Prakash, about Kubernetes, which I just explained in the short.
Yes. Yes.
Okay, because these are the core. Okay.
Okay.
If you have any doubts, you can ask me. I can repeat again.
No, it's clear for the moment, so we should be okay.
Mhm. Okay. So whatever you can grasp about Kubernetes, that should be enough, because it's a very detailed topic. I do not expect you to like uh, be a master of Kubernetes with just 4 or 5 hours of the session. Okay, that is literally impossible. For Kubernetes, to study Kubernetes in detail, like uh, you'll have to go through a separate course that cannot be
Okay.
covered in like 3 or 4 hours. It's impossible.
Yeah.
Okay, but yeah, for the basics, what is Kubernetes and how, what are Kubernetes objects, and just the basics of how does a manifest file looks like and all those things. We'll go through it. Okay,
Okay.
and there are two ways. Like I also told you, there are two ways of user interacting with the Kubernetes cluster. So user actually fires the commands. Correct. Whatever configuration he wants to do, he fires a command. So he fires a command using kubectl. Okay, he writes a command kubectl. So he can do it with a command, whether like for example, if you want to create a container here, okay, if you want to create a pod, let's say if you want to create a pod, he can do it with a single command. Okay, he'll fire a command and it will work. He can also create manifest file. Manifest file is like a code, it's like a YML file. He can write a manifest file, and then manifest file he can write whatever he want. Create a pod, create a load balancer, create a volume, create a this whatever XYZ, whatever things he want to write, he can write all those things in that manifest file. And when he applies that manifest file, all those things will be applied step by step. Okay, similar to Ansible. Like Ansible we saw, right? And Ansible also we could do Ansible, fire some Ansible commands, ad hoc commands, uh, like direct Ansible, do this Ansible module -m, something like that. So that was the way. Another way was creating a playbook. Playbook was a code where we used to write everything and we used to just play it, and all those steps will be executed sequentially. Okay, so similar to this, here we have a concept of manifest file. Okay, we have a manifest file. In that manifest file, we write all those stuff, all the code, all the configurations that we want to do, and we just apply that manifest file, and whatever we write there gets applied. Okay, gets executed. So those are the two ways. So we'll see both how the things are done. Okay, so let me share my EC2 console. Mm. So yeah, Kubernetes is not easy. It's a bit complicated. Like the topics which we have studied so far, Docker, Jenkins, and SonarQube, Nexus, they were very straightforward. Okay, but Kubernetes is a bit complicated. So that's why we have a different certification, right? That's the idea of everything. So uh, let's okay. So okay. So I'm sharing. I'm sharing the full screen now. Hmm. So we'll go with the concept of one master and two nodes. In the demo, we'll go with the concept of one master and two nodes. Okay, so I'll give you this document, like how to install and everything. because installation is not very straightforward. Okay, so okay, there is a page which we'll go through. This I found was like you in on Google you will see many if you search installing Kubernetes on this is a blah 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 whatever, most of the links you will find there are they are expired, and most of the things will not work. Okay, so this page I found, this is pretty good. Okay, this most of the things here work. Okay, so we'll go it step by step. Okay, so the first step says, yeah, the first step says we have to create three Ubuntu 18.04 servers. Okay, server 1, server 2, and server 3. Okay, and you see minimum requirement of Kubernetes is having at least two CPUs. Okay, it requires at least two CPUs. Okay, so let's see which of the server fits our job. So I'm launching three instances. You can see my screen, Prakash.
Yes. Yeah.
Okay. Okay. So let's launch three servers. So I'm selecting Ubuntu. I'll make number of instances as three. Okay. And I'll let's select 18.04. Okay. You can select any version. Uh, but this document says 18.04. So let's go with 18.04. Okay, and instance type, yeah, instance type. See, minimum requirement of this Kubernetes cluster is like nodes and master of Kubernetes is at least two CPUs. Okay, so T2 medium is the least we can find. Okay, T2 medium has two CPUs. T2 micro will not work here. You have to go with T2 medium. So it will incur some charges, but it will be very small. It's 0.064 USD per hour. So you can do the lab and just delete it afterwards. So it will not charge a lot. Okay, let's select the key. Okay, security groups. So security groups you can in your production and your offices, obviously we'll select some strict security rules. But for here, let's allow all traffic. Okay, I'm allowing all traffic for now because this is just a demo. Okay, we don't care about security and all those things right now. Okay, number of instances is three. So I'll launch instance. Okay, let's see the instances. So it is launching three instances. So all three instances you see, they are of similar type. Okay, T2 medium, T2 medium, T2 medium. Okay, so let's make one of these three instances as master and other two instances as node. Okay, I'll call it as I'll call it as master. Okay, this is my master, and other I'll call them as node 1 and node 2. Okay, node 1 and node 2. Okay, these three. Okay, now let's start logging into them one by one. So let me delete the old stuff. Let's log into the master first. Oh, sorry. So this is our Ubuntu. Okay, let me change something here. Settings. It's not coming. Network issues or what? Okay, I don't know why it is hanged. Let's connect again.
it's still starting, right? I mean, is it started now?
I guess it is starting. Maybe that's why.
Okay.
Okay, let's see. Let's see. Let's try again. It should have started by now. Open to. Oh, sorry. NTU. Ah, yeah, it's there. Okay, so I'll change its color just to make it more visible to you. I'll make it default background as white. Again, foreground, let's choose blue. And appearance, let's make it the font size, let's make it 12 and a bit bold. Okay, this looks good. This is my master. Okay, master is white and blue. Okay, and let's log into the nodes now. Okay, so this is my node 1. I'll leave it black only. Okay, I'll just change the. Okay, this is my node 1, and similarly I'll log into my node 2. Hmm. Hmm. Okay, change setting. Okay, so the black ones are my nodes, and I log in as root user and all, and the white one is my master. Okay, so let's go with the installation now. Okay, so it is asking to change the set the host name of the servers. It's optional whether you want to do it or not. So let's do it. Okay, master will change the host name. Okay, so right now you see IP, this is visible. So later on you will see that if I do sudo again, so now it has turned to master. Okay, so it's optional step whether you want to do it or not. Just to make sure that okay, this is my node 1 and node 2, just a label to them. Let's on the black, any of the black one, let's name them. Okay. Okay, so this is my node 1, and I'll do the same here. I'll call it node 2. So this is an optional step. If you want to do, you can do. If not, you can leave it. Okay. Then yeah, other step is you have to install Docker. Okay, because I told you Docker is mandatory on all the nodes. So in this installation, some of the steps we have to do on all the nodes. For example, master node as well as our worker nodes. There will be some steps that I have to do only on the master node. There will be some steps that I have to do only on the worker nodes. Okay, so we'll see what are those steps. Okay, first step is related to Docker. Okay, so first we have to get the Docker JPG key and so all these are Docker related formalities we have to do. And step one is to install Docker, because having a Docker is a prerequisite, because Docker is a container engine, right? And Kubernetes cluster, Docker is an important part, because all the containers and everything that we are going to create is via Docker only, using Docker only. Okay, so let's do it. So we'll do this command on all. So it's written, execute the following commands on all the nodes. Okay, so these commands have to be followed on all the nodes. Okay, let's start with the master. Okay, this is about adding the key. So okay. Okay, now now we have to add a Docker repository. The same can be copied just to verify that yes, command is fine. Okay, press enter. I'll do the same on the nodes. Okay, so whatever commands I'm firing on all the nodes, like master node plus worker nodes. On all those nodes, I'm firing those commands. So looks like yeah, reading package list done. Okay, now what is the next step? Next step is now here our Kubernetes installation begins actually. So first step was about Docker. Same thing, we have to add this GPG key for Kubernetes. So this also we have to execute on all the nodes. Okay. Mm, mm, okay, done on all the nodes. Now coming to the next step. So now similarly adding Kubernetes repository. So copy this. This will add your the Kubernetes net repository on your nodes. Okay, so add here. Oh, there was some issue, I guess. There was some issue here, I guess. Let me do this again. There was some issue in the node, I guess. I did not copy correctly, maybe. Okay, so let's copy it from here. It will copy correctly. This step actually. Okay, now it's done here. Let's do it here as well. And on the master. Okay, on the master it's already done. I'm done already. Okay, now coming to the next step. Add Kubernetes repositories. This adding is done. Okay, then we have to update the packages. Okay, so this also has to be executed in all the nodes. Let's do it on all the nodes. Okay, so this is also done. Package update done. Now, so we have added the repositories right now for the Docker, Kubernetes, and all these. We have added repository. Now let's install it. Okay, now we have to install Docker, Kubernetes, and all those components. Okay, so the command is apt get install, and you can see what are the versions of everything we are installing. So we are installing Docker, we are installing Kubelet, we are installing kubeadm, and we are installing kubectl. Okay, Docker we already know what it is. Kubelet we already seen what it is. Okay, kubeadm, it's for management. It is required. Okay, this is also, and kubectl. This is for executing the commands. Okay, so let's install all these components. So this has to be done on all the nodes. Okay. Uh, yeah. Now whatever we have installed, we have to hold them for the current version. For whatever versions we have installed, we want to stick to them. Okay, so that it does not change. So we will use this apt mark hold docker c for all those three softwares that we installed: docker c, kubelet, kubeadm, and kubectl. We will hold them to the current version. Okay, so this also has to be executed in all the nodes. Okay, set on hold is written. Executing on this as well, executing on node 1 as well. Okay, done. Okay, now add the IP tables rule to sysctl conf. So this also you have to do on all the nodes. Okay, don't go into detail what these steps are actually doing. So these are just installation step. This has to be executed on all the nodes. So if you want to go into a lot of detail, then you can study about them. What is IP tables, and these are generic concept of Linux. Like if you have done Linux administration or anything, so you will know these concepts. But yeah, not as a DevOps. Like if you want to know, you can know, but there are so many things. So it's just installation. That is uh, that is actually what we want to do on Kubernetes: installation and managing the nodes, not how it is getting installed and all those things. Okay. Now, now we do sudo sysctl minus p. This also has to be done all the nodes. Okay. Master. That one. This node as well. I think I did on all the nodes. Yeah, on all the nodes. This step done. Now, yeah, till here, all the steps have to be on all the nodes. Okay, master as well as on the worker nodes. Now, this step has to be done particularly on the master. To initialize, this is the step to initialize the cluster. Okay, cluster, we know what is a cluster, right? Cluster is a combination of master and worker nodes. Okay, so in our example, whatever demo we are doing, our cluster contains one master node and two worker nodes. Okay, so this is the command. So all, how to manage a cluster? Cluster has to be managed on the master only, right? The whole cluster has to be managed on the master only. So we have to install, we have to initialize the cluster. Okay, this has to be executed only from the master. Okay, so we'll select it. Okay, this takes a bit some time. Mm. So it is, see, if you read the logs, you will see everything. Well, how it is initializing everything. It is generating etcdca. You see, etcd cluster, etcdca is getting generated. Then API server, like all those things it is getting. When a cluster is initialized, all these things are getting created. See, for configuration file for everything is getting created. Kubelet.conf, control manager.conf, scheduler.conf. Okay, Kube API server, Kube control manager. Okay, all these are Kubernetes components. Okay, all these things are getting. Done. Okay. Now your cluster has been initialized successfully. So it says your Kubernetes control panel has initialized successfully. Control panel is what? Control panel is on the master only, right? We saw in the slide, right? This is also called control plane. Okay, this when you initialize a cluster, so you manage it using a control plane. Okay, so we did an initialize command, and you see everything got done, and it says your Kubernetes control plane has been initialized successfully. So our Kubernetes control plane has been initialized now. Okay, so now it says to start within cluster, you need to run the following as a regular user. Okay, so the same thing we have to do it saying that mkdir -p home. It is we are actually creating a .cube directory. Okay, and that this admin.conf that just got created, we are moving it to .conf .cube slash config directory. Okay, we are moving the admin.conf to this config directory. Okay, and then we'll do we'll change the owner. Okay, we'll change the owner. Okay, so we can copy this command. Yeah, we can copy these one by one. So this also has to be done in the master only. Okay, you don't need to do everything these things on the on your worker nodes. Okay, so these three commands done. Now you see at the end it's saying that you should now deploy a pod network to the cluster. Okay, pod network means so there is something an external thing. Okay, we have to do something externally for creating the networking. Okay, there are packages which are available that help you in the networking part. Okay, so it says that run kubectl apply -f this pod network.yml. Okay, so this is how a manifest file you execute a manifest file. Okay, there can be a manifest file with any name xyz.yml. Manifest file, I told you, right? What is a manifest file? Manifest file contains all the configurations that you want to do on Kubernetes. Okay, whatever configurations you want to do, that manifest file contains everything. Okay, now whatever changes you have done in the manifest file, just to apply that, you have to use this. Okay, kubectl apply -f. Okay, so it says we have to deploy a kube network. Okay, so let's move to the next step. You will see. Okay, so it says that here it says apply flannel CNI over network overlay. So there are many different types of network available. So this is here they have given the example of flannel CNI. Flannel CNI is one of the thing. Okay, but there are many. But there are many type of. Some will work with you, some will not work as you planned. So there was one which I found that was working very properly. This was this Weaveworks. This was from Weaveworks. Okay, so you have to apply this. Okay, so I'm applying this. So actual command how to get the nodes. Okay, now with this part, okay, so we'll see that. Okay, till here it's clear, right? Whatever things we had in the master till here it's clear, right? So we deployed
Yes,
everything
sir.
and our control plane got initialized successfully, and we moved that. We created a .cube directory, and in .cube and this admin.conf we moved into a .cube slash config path. Okay, and change the permissions. Now I told you we have to deploy a network, like we have to install something to help in the networking aspect. Okay, so I told you there are multiple tools available in the market which help us to do that. Okay, there are something like Flannel. I told you that Flannel CNI. There is something like that. There is VNet from Weave Networks. There is something like that. Okay, there are a few other things available in the market. Okay, we'll do that, and after that, you see here, how is it showing? Then it's saying then you can join any number of worker nodes by running the following on each as a root. Okay, now it says that now you have configured, you have initialized your control plane on your master. Okay, now you have to join your worker nodes to your master, right? You have to create a connection. Okay, so worker nodes, you have all the two worker nodes. Okay, so now you have to do some connection so that your worker nodes can be connected with that master. Okay, and it gets integrated with the cluster. Okay, right now they are separate, so there is a command how to check it. Okay, so there is a command how to check it. So the command is this. Command is kubectl get nodes. Okay, kubectl. So whatever Kubernetes commands will be firing using kubectl. I told you, right? kubectl is a way of firing command. It's a tool how you fire the commands. Okay, whatever commands you want to fire, you use kubectl, and after that command. Okay, so get nodes is a command to get the number of nodes, get the nodes attached with this. So see, right now, if I fire kubectl get nodes, what will I see? It says only one. You see, it says only one name, master. Okay, and that also status is not ready. Okay, you see status is not ready, and it has age, it has been created 6 minutes 41 seconds before it is on this version. Okay, now we have to, okay, so two steps are pending. First step is let's install a networking thing. Okay, let's install the networking software. That means this kubectl apply -f https github blah 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 whatever vworks daemon set. Okay, let's install this. Okay, and this has to be installed only on the master, not on all the nodes. Okay, only on the master this has to be installed. So we'll apply this. Okay, and it says it created. So it created cluster role bindings, and these are some advanced concept. Role bindings, daemons, this cluster roles and everything. These are very advanced concept. RBACs and everything. So I think if we have time, I'll give you the basic, just a basic. We'll not go into a lot of detail, because of if I start going into a detail of every topic, so it will easily take 30-40 hours minimum for Kubernetes everything. So yeah, so this is done. Now if I show you, if we do kubectl get nodes again, you will see status is ready. Okay, now status is ready, but now our other task is to connect our other nodes with this mask, with this cluster. Okay, so we saw that it is saying that we have to use this command. Just copy this command. Just copy this command, and this command has to be fired from all the nodes, all the worker nodes. If you fire all these commands to the worker nodes, those worker nodes will join this cluster. Okay, so let's do it. So let's run this from here, the same command. Okay. So see, it is trying to, yeah, so it says this node has joined the cluster. Okay, so now we'll do the same for other node. Okay, so this node has also joined the cluster. Okay, now let's see on the master whether we see it configured or not. Okay, so what we'll do, we'll again do Kubernetes get nodes, kubectl get nodes. You see, now you can see two nodes, node 1 and node 2. Okay, now you see master, node 1, node 2. All these two nodes have joined the cluster. Okay, so this is how my cluster looks like. Clear?
Yes.
Okay, so this is the basic installation of a cluster. Like in a cluster means one master and multiple nodes. Okay, so so this is the ideal thing that we do in our offices, in our organizations. Okay, in our organizations, in our projects, we'll be having one master and multiple nodes. Okay, we'll be having one master and multiple nodes. But in demos and trainings, what we usually do when we are doing demos as well in the offices, in the project, when we are doing some POCs and all those things, so we'll not create three different nodes. Okay, we'll not create master and different nodes. because it will cost us, correct? And managing 3 servers is difficult. Okay, so what we'll do is we install a software called Minikube. Okay, we install a software called Minikube, and in that Minikube we can have all the 3 things in a single node. Okay, all these 3 things will be in the single node. There'll be a single node, and that in that single node we can do everything. Okay, so I tell you how to install Minikube as well. Okay, so this is clear, right? This installation is clear.
Yes, it's clear.
I'll
Oh, I
give
mean,
you. Hmm.
is that all? I mean, like, see, when we issue that command, right, kubectl get nodes,
Uh-huh.
it's not telling the role of the nodes, isn't it? Or do
Uh,
we need to define the role?
Role is
Role.
something else. Role is something else. Okay, that is a
Mm-hmm.
different concept.
Yeah.
That is a different concept.
Uh-huh. But it should say none for nodes, yeah? Is
Yeah,
that correct?
for node, yeah, this is expected. This is expected.
Okay, okay, okay.
For nodes, it will say none. Okay, you can
And
give your roles.
also the versions, if the versions are not matching, what will happen? Like, so nodes are having different versions. Will it not work?
So while installation, whatever installation you are doing, so those that will happen. Uh, so it might give a version mismatch, but we usually do it. What we usually do, we create it on the same version, because
Mm.
we're installing Kubernetes only, right? We installed Kubernetes, the steps which we did on all the nodes. You see
Uh-huh.
all the above steps which we did here. You see, this command was fired on all the nodes, right? We installed Docker of 18.06 version, Ubuntu, then sorry, this was then Kubelet. Kubelet was installed for 1.1.15.7. KubeADM was also installed on the same version. So we usually what we do, we install uh, everything on the same version on all the worker nodes and the master. Okay, just to keep everything consistent. Okay, so if we want that, okay, kubelet should be of a different version and those things, then it might give a mismatch depending on uh, compatibility, because in different versions they introduce different things, right? Let's say in version 1.18, if you install uh, if you install kubelet 1.15 in master and kubelet 1.18 in worker nodes, so it might give compatibility issues if the packages are different. Okay, if there are minor changes, if it does not find any conflict, it will not give any issue. Okay,
Yeah, that's fine.
so we usually keep it same. Okay, we usually keep it same.
Mhm.
Okay, so this was creation of uh, a cluster. This is how we created a cluster. Okay, now I told you, right, in our demos and productions, what we do usually, we create a single node, and in the single node only we manage everything. Okay, we do some installations, and using it we manage all those things in that single node only. Okay, we'll install that a single node tomorrow. We'll do that, but before that, let's go through some theoretical aspect, because we'll be doing some more demos tomorrow on the single node, on the networking and the volume and labels and all those things. Okay, so just to give you an overview of all those concepts before we do the demo. Okay, so this was it. This was just an example. Like in industry, if you see this kind of setup, so do not get surprised. Okay, because usually we have this kind of setup in industries. You have a master and you have multiple nodes. Okay, and whatever uh, commands you want to fire, like if you want to create a pod, okay, your pod can be created in any of the node 1 and node 2. Okay, so you can define on which node you are going to create a pod. You can give the instruction in the command that, okay, I want to create a pod in this node, or I want to create a pod in this node. Okay, so the pod which you are firing will be created only on the node which you specify. Okay, that you can specify in your normal ad hoc command, or you can specify in your manifest file as well. Okay, or other thing what you can do is, or if you do not specify, it will be created randomly. Okay, it will be created randomly, because these node 1 and node 2 are machines only, right? These are the actual node 1 and node 2 are actual machines, are EC2 instances. So let's say if it is lower configuration, okay, and you are creating a pod that requires some higher configuration, okay, and node 1 is for of higher configuration, and node 2 is of lower configuration, and you give a command to create that particular pod which is of higher configuration, then obviously it will be get created in the node where the capacity is sufficient, in a higher capacity node. Okay, so this everything is managed by kube scheduler. Okay, I told you, right? Kube scheduler is like a employee. He works like doing the actual he's actually doing all the things, scheduling all the pods, where the pods are getting created and all those things. Okay, it is intelligent in its own way to do all those stuff. Okay, so you have various other commands, kubectl. So commands are very easy. Okay, commands are very easy. If you are creating a manifest file, if you want to apply any changes on the, like I told you, right, in the manifest file, you write whatever changes you want to apply. So let's say you created a manifest file called abc.txt. So how will you apply for it? You will write kubectl apply -f and name of the manifest file. Okay, so this will apply your changes what you have done in the manifest file. Okay, and you can get the information of pods also, whatever pods are. So you can go kubectl get pods. Okay, so this is also a command. So right now I have not created any pods, so it is saying no resource found. Okay, it says no, nothing found. Okay, so just to give an idea how this pods look like, it looks like this. Okay, it looks like this. Manifest file, sorry, the manifest file looks like this. So manifest file starts with the kind pod. Okay, it starts with kind. So what is a kind? Okay, so before that, let me tell you uh, uh, Kubernetes objects. Okay, so in Kubernetes, everything is an object. Okay, in Kubernetes, everything is an whatever you will see is an object. Okay, so pod is an object. Okay, volume is an object. Okay, load balancer is an object. You have various type of deployment objects. Okay, we'll see that what are these objects. So for now, in kind you specify what type of object it is. Okay, so I told you, right, everything is an object. So here it says we are creating a pod. Okay, so pod is an object. So we say kind pod. Okay, then API version we say v1. Then in metadata we can define like a tag, you can say. Okay, you can define a tag for that pod, you can say. Okay, so metadata is like data about a data, right? About you're creating a pod, and if you want to give some tags to the pod, for example, name, test pod. So we are giving a name to this. pod. Okay, this pod will be called test pod. And then you have to write spec about the specifications of this pod. So this pod contains, and inside the specs, you mention containers. Okay, so we know, right, inside the pods you can have one or many containers. Okay, so this is an example of a single container inside the pod. So how you write it? You write a spec inside spec, you write containers. Okay, and after the containers you specify all the number of containers you can have. Okay, so this is an example of one container. So here put a dash, and this is one container. Okay, this is a container here written here. Similarly, you see there are, if you want multiple containers, see how you write a multiple container. You see, kind pod, API version v1, metadata. This is another pod. Let's call it test pod 3. Okay, and spec, uh, containers. Name of the container is this. It is being run from this image, and the command is this. What is the command you want to execute when a container spins up? Okay, like the same thing. Whatever we learned in Docker, now it applies the same thing here. Okay, how you specify, how you do that in the Docker? You pull an image, you specify the base image, right? We saw in the Docker file, we write that base image. Okay, we write from which base image my container is going to get created, and all the commands that I want to run. Okay, we saw in the Docker file, right? We had a run command. Okay, we used to run, then whatever command we used to write, like touch A, touch B, touch C, all those three files will get created. Then we could also do echo something with the run command. We used to do run and echo, and that used to get echoed. So the same thing here. Okay, here also we are creating containers only, right? So here you are telling it to create containers. You are telling that, okay, this a pod will get created, and that pod will contain one container. The name of the container would be C00. The image that the container would be having is Ubuntu. The command which will get executed when the container runs is this. Okay, what is this command? It is running a /bin/bash first, and then it is running this in loop. Okay, this is running in loop. See, while true, do echo hello Puneet. So hello Puneet will run in loop. Okay, and it's sleeping for 5 seconds. Okay, this is a loop I have applied. So it will sleep for, it will print hello, it will print hello Puneet and sleep for 5 seconds. Okay, this will keep on repeating. Okay, so similarly here we have two containers. Okay, container this and container this. Okay, so both these containers are being run from Ubuntu. Okay, and the command that you're using here is these two commands. Okay, so you can write these in your manifest file. Okay, so we can create a manifest file here if we want. So then you can specify the restart policy. Okay, for this pod will have a parameter called restart policy. So inside spec you can write multiple type of specs. Okay, you can specify the containers. If there is you are creating a volume, you can create a volume. If you are creating a port, you can expose a port from here. Like all these things are you can do it from here. Okay, all these things you can do it from here inside the specs, inside the specification. Okay, so all the logic you can say that all the logic is actually written in the specs. Okay, so you can create a manifest file using it. Just again. Okay, sorry. So yeah, so let's create a manifest file here. So right now what I have here, there's nothing. So let's create a manifest file called pod1. Okay, I'm creating a manifest file called pod1. So right now you saw Kubernetes kubectl get pods. I do not see any resources. Okay, because pod there are no pods. So let's call it yml. Okay, so this is a yml file. Okay, all the manifest file will have this extension. Okay, pod1. Let's call it pod1.yml. So let's write that. Oh, not copying correctly. So let's align it. So yeah, since this is a YML file, obviously you have to align everything and avoid all those spaces because it will give a lot of errors. Mm, sorry. Okay, wait, I'll do something about it. Where is my notepad plus plus? Ah, it was installed, right? Hmm. Okay, let's copy paste it here. And in this, I'll do an edit. And I'll blank operations, trim, trailing space. Okay, those spaces are removed. Okay, let's see. I guess this is done now. Why is it not copying correctly? Hmm. Okay, let's align it. Because indentation is very important here. Okay, if you give any of the wrong indentation, it will give an error. So do this. Parallel to name, and after that you have to put some spaces and this, and now everything has to be aligned with the name. Image. This demo actually I wanted to show you with Minikube, but yeah, that is fine. With Minikube also we'll do it. Okay, looks fine now. Now just let's save it. Okay, my pod.yaml is created. Now how to apply it? The command to apply that is kubectl apply -f pod1.yml. Okay, you see, it says pod test pod created. Okay, so this is how I apply. This is my pod1.txt pod1.yml is called a manifest file. You see, this is how my manifest file looks like. Okay, it starts with kind, what kind of it is. For now we are creating a pod. Okay, and you see all the specs. So it has containers. It has one container right now. Okay, so I just ran it and it created a pod. So, but I don't know where it has created the pod. It might have created in any of the two nodes. Okay, now what is the command to see all the pods? Kubectl get pods. You're there, right, Prakash? Connected?
Yes, yeah.
Okay, you see, it says now test pod is created. Okay, its age is 52 seconds and it's running right now and it's ready. And 1 out of 1 means there are just one container in it and that is in the ready state. Okay, and similarly I can create multi-pod. I can create multi-pod as well.
Yeah.
Okay, so okay, let's show you that as well. So I can do cp pod. I just copy this pod and to pod2.yml. Okay, or multi container. Okay, let's call it pod2. You'll understand. Okay, so okay, so if I do vi pod2.yml, so I just have to add multiple containers there. So let's copy this stuff. Alignment part is important here. Okay,
Yeah.
that is the worst thing about even a single space will make it fail.
Is there any other editor for this?
You can use your editor, whatever editor you want. You can do it in Visual Code, Visual Studio, or anywhere you can do. You can do it on Notepad++. But it's a small pod, so it's a small 3-4 times. So I was using it. Oh, sorry, I have to change the container name. Let's call it C01. Okay, this is also based on Ubuntu. Let's print something else here. Hello, Kubernetes. Okay. We saw there is only one pod running right now. Okay, test pod. This. I also have to change the name of the pod then, else it will give a conflict. Okay, let's call it multi-container pod. Okay, so again I'll do the same thing. I'll do kubectl apply -f pod2.yml. Okay, so it says that multi-container pod created. So right now I have two pods. Again, if I see what are the pods, you see I have two pods. Multi-container pod contains two containers. Both of them are ready state, and this test pod contains one container, and that is in the ready state. Okay, and you see the age as well.
Yeah.
Now there is a command to get more detail about these pods. Okay. It's simple. Very Kubernetes commands are very easy to learn. Okay, so just to get more information of these pods, you have to do -o wide. Okay, this is giving a bit more information. Okay, node 1, node 2. So see how it is. I did not select anything that I have to specify this pod into node 1 or node 2. It is automatically doing it. You see node 1 and node 2. The first pod, it got created in node 2. Second pod, I created multi-container, it got created in node 1. Okay. You see the age of these pods. It's 47 seconds, and an IP also got associated. You see, IP of this pod is 10.44.0.1, 10.36.0.1. So right now we have a EC2 instance. Okay, in that EC2 instance, we have two pods running. Okay, multi-container pod and test pod. Multi-container pod is having two applications, like two containers, and test pod is having one container. Okay, and you have the IP of these IP assigned to these pods as well. These IPs are obviously used for communication. So if this particular pods want to communicate with this, he will know. It's a unique identifier, right? Like a normal IP. So this IP is internal to your pod right now. Okay, it's internal. Right now, public cannot access it. So we have to do some other things for public to access it. Okay. Now, other command is to describe any particular pod. Okay, right now we see two pods. So let's describe any other pod. So the command is kubectl describe pod space name of the pod. Okay, see it is giving you more detail. Oh, sorry. So here we did. So we did a command kubectl describe pod test pod. Okay, and it is giving me all the details. It's giving me which namespace it is. It is in default namespace. What is the IP of the node? You see this IP. It is showing you where it is. It is giving me node 2, and it is giving me also the IP of the node 2. Okay, all these details you see all the it's giving minute details about that pod. What was the start time? Do you have any labels or not? We'll come to the labels part as well. Okay, you see IP of the node 2. This is my IP of my EC2 instance. Node 2, like this one. You see 172.31.23.231. So which node is it? It's node 2, I guess. Yeah, this is the node 2. If you go at the top, yeah, you see 172.31. So it has been scheduled here. It has been created here. Okay. Then it says that okay, it is running one container which is called C00, and it does not have any port. We can specify the port as well. It is saying okay, this container which this pod is having, it is having Ubuntu as the image. Okay, and what is the command that we have triggered? We have triggered loop, this particular loop. Okay, and volume related stuff, conditional. We'll see that. Okay, these are for the basic. That is fine. Don't go into a lot of details about everything, but it also gives you the events. Okay, it also gives you the events. How what all started? We started the container, then uh, uh, created. So it is giving you the brief idea of whatever happened with this particular thing and who did it. So first, what to do? Default scheduler will schedule it. Okay, default scheduler scheduled it to node 2, successfully assigned. So you saw the flow, right? Flow is clear. Me as a user, what I did? Me as a user, I fired a command to execute my manifest file. API server took it and it forwarded it to the control manager. Now control manager is actually doing everything. It will take care of that my desired state is equal to actual state. Now its control manager saw that okay, this person has given a task to create a pod. Let's see if there is a pod here or not. It shows that oh, there is no pod running in any of the nodes. The name of this particular pod with this name is not running in any of the nodes. So I have to make sure that actual state is equal to desired state. What is the actual state? There is nothing running. What is the desired state? Desired state is a thing what user desires. User desires that a test pod has to be created in any of the nodes. And the user has not given any specification that on which node the test pod has to be created. Okay. So the manager tells Cube scheduler, okay, it's your job now, do it. So what Cube scheduler is doing? Cube scheduler randomly chose a node 2 and it successfully assigned the creation of this pod on node 2. Okay. Now after it got assigned, now it's now the job of the kubelet, because the kubelet is the king here. On the nodes, kubelet is the worker, not the king. It's a worker. It is actually doing the things. So now kubelet is what kubelet will do? Kubelet will create pods. So how will it will create pod? Sorry, kubelet will create the pod and it will create a container. Kubelet will create containers. So how will it do? It like all the specifications that we have given in the container, that okay, pull the image, Ubuntu, and run the commands and etc. All those things, and then it created the container and then it started it. Okay, so all these things you see here. Okay, there are a lot many things here. You see volumes. You have a concept of volumes here as well. Conditions. Then you have taints and tolerations. Okay, so a lot and node selectors. Okay, so there are a lot of concepts in Kubernetes. Okay. Okay, this is clear.
Yes.
Okay, now let's go inside the pod. How to check the logs of the pod. Okay, how to check the logs inside the pod. So uh, so there are two pods running. Okay, test pod and multi-container pod. Let's see the logs inside the test pod. Command will be kubectl get logs -f. Sorry, not logs, only logs. Kubectl logs -f and name of them. So this will give me the logs. You see, Hello Puneet is running in infinite loop. Okay.
Yeah. Okay, this is like it shows you the real time, yeah?
Yeah, it will show you the logs, what is running. See, and every 5 seconds,
Okay.
I have put a sleep. Right after 5 seconds,
Yeah.
this is getting printed.
Okay.
And you can get the pod of a specific container as well. Now, this was a single container, right? Test pod has a single container, but my multi-container pod has multiple containers. Oh, you see, I have two containers here. So how to get the pod of any of the two containers? Sorry. So the command is just the same. It's nothing different. Okay. Get pods. The name of the pod. Let's call it. Let's check the pod of. Let's check the logs of a container two inside multi-container pod. Okay. So the command would be -c -c and the name of the container. The name of the container was C01, I guess. Unknown short hand
Are we
flag.
trying to get the logs?
Yes,
So
yes,
it
we are
should
trying to
be,
get the logs of.
yeah, CSV key cube CTL logs or something.
Sorry. I posted something wrong here. Yeah, here I wanted to append. Sorry. Uh, what was the name of the pod? So to get the logs was kubectl. Okay, leave it. Let's type it. Not to be too lazy. Kubectl logs -f name of the container. Sorry, name of the pod -c and name of the container. Let's say it's C01. You see, it is saying hello Kubernetes.
Yeah.
Okay. So now similarly you can see the log of C00 as well inside it. It's saying hello Puneet. Okay. So that you can
Okay.
check whatever you want. Okay. Now you can delete the pod as well. So how to delete a pod? Oh, why do LSI run LSR? So to delete a pod, just it's a very simple command. Mm, kubectl delete pod test pod. Okay. Kubectl delete pod name of the pod. Okay. It says that this pod is deleted now. That takes some time. Okay, so this pod got deleted. Now again, if I do get pods, it will only show one pod. Okay, multi-container pod. Okay, so mm, So this was a basic manifest file, okay, which we used to create the pod. Okay, let's copy it. And copy it here properly. That was having a lot of spaces. Now this should be fine if I do for Part2.yml as well. So you have a concept of namespace here as well. Okay, so namespace is like uh, it's like an area. Okay, namespace is like an area where you are creating the pods. Okay, for by default, your pods which are getting created, they are in the default namespace. Okay, by default, the pods which you are creating are in the default namespace. So if we see the logs that we got earlier for this, yeah. So we did this command, right? Describe pod. Okay, let's describe it there as well. Let's do that. Describe pod. So let's describe multi-container pod. Multi. No, I guess multi-container only. Okay, so see here it has a thing called namespace. Do you see any namespace here? Environments, mounts, default token, default token, containers, labels. Labels you'll see now what it is. It should be a name as
It's
well.
there in the top, the second one. So name
Yeah,
and
yeah, yeah.
namespace.
Oh, yeah. The second one only. Namespace is default. Okay, so by
Hmm.
default, whatever pods you are creating, that gets created in the default namespace. Okay,
Okay.
but you can always specify if you want to create a customized namespace, you can create a namespace as well.
Okay.
Okay, you can create a namespace, and while creation of the pods, you can specify that okay, this particular pod has to be created in this namespace. But this is a very handy feature. This is a very good feature because in organizations, what we see, we can have hundreds of pods. Okay, we can have hundreds of pods of different applications running inside the same instance. Okay, let's say you have one master and 10 worker nodes. Okay, I'm talking about a big configuration right now. You have one master. So right now, what in our example, what we did, we had one master and two workers. Okay, but in organizations, you can have one master, like multiple masters, like 4 masters and 20 nodes. This configuration also you can have. So in those 20 nodes, there can be hundreds of pods running, right? Hundreds of pods
Yeah.
based on different projects. Okay, some pods of different projects, other pods of the other project. Okay, then how do you identify that which pod is of different project? It will be very difficult to find out, right? If you want to find a pod for a particular project, it's very difficult to find out. So we create a namespace. Okay, you create a namespace for different projects. Okay, and whatever pod you are creating pertaining to that project, you will specify that okay, create this pod into this particular namespace. Okay, and all those commands, now that whatever commands you are firing, you have to specify the namespace there. Okay, uh, to describe pod, to get the nodes. So if I do this command get node, sorry, if I do kubectl get pods, so this will get the pods of only default namespace. Okay, but if I specify a pod inside a namespace, then I have to use kubectl get nodes hyphen namespace and namespace name. Okay, then only it will identify that okay, this pod is there in this namespace. Okay, got it? Got the concept of namespace?
Yes.
Okay, then you have the concept of labels. Okay, labels are like labeling your pods. Okay, labels are just giving a name to the pod. Okay, so we have that concept here of naming the pod. So okay, before that, let's see environment variables. So if you want some environment variables specific to your pods, so this is how you define it. Uh, After this, env, like this thing is same. Okay, this thing is exactly the same. Creator on containers, but here you specify the environment variables, list of environment variables which is to be used inside the pod. Okay, so you specify by this env and this name and value. Okay, this has to be key pair. Okay, like a normal environment variable, like we have environment variables, we can create environment variables. So wherever I'm going to do echo of my name inside my pod, it will give me Puneet. Okay, this is just for creation environment variables. Okay, similarly, just for the ports, if you want to expose a port, okay, in Docker we saw that, right? Why do we not need ports? What is the difference between attach and publish and expose? Okay, so we could expose ports of our containers. Okay, similar, the same concept is here with the pods. So in the pods, you can have a port. You can expose a port for every container. So every container, for every container, you can expose a port. Okay, let's say there is an application running on port 80 in this container. So what we did, we can do ports, and after that, container port 80. Okay, so it will expose it. It is like similar to expose command that we used to have in Docker. Okay, so it will expose the port 80 of this particular container. Okay, then coming to the labels. Okay, labels are a way to identify your pods. As I told you example, right? The first identifier you can make it is create a different namespace. Okay, let's say you have 1,000 pods to be scheduled in to be created in your 10 worker nodes. Okay, now you have created different namespace. You have created 10 namespaces. Okay, 100 pods in each namespace. Okay, but now every namespace is having 100 pods, right? Even then it is difficult to identify which pod is doing what. So we give them labels. Okay, we give them labels. Okay, that you can give them, again, this is in the form of name key value pair. Okay, again, this is the form of key value pair. You can specify labels. Okay, in the labels you can specify, okay, this is a environment. Here the name of the environment is development, and then the class is pods. Okay, whatever you want, whatever name you want to give. Labels, it's like a tag. Okay, it's like a tagging of your EC2, similar to that tagging of your EC2 instances. You do similar to that. It's like a tagging of your pods. Okay, then you can, then it comes node selector. Okay, node selector is you can specify like in which node your pod has to be scheduled, your pod has to be created. So for us, we did not use any node selector, so our pods were being created randomly. One pod got created in node 1, another pod got created in node 2, but I have an option to create a pod in a specific node. Okay, so for that I use node selector. Okay, so node selector is a command here. Okay, node selector is a command here, and I can specify n number of things here. I can specify, okay, hardware T2 medium. Okay, this will create uh, my pod inside a node that is of T2 medium. Okay, for example, I have in my example what we did, we created two nodes which were of the same T2 medium, T2 medium, right? Now let's say there is a node in T2 micro, something like that. There is a node T2 micro. T2 micro is not supported, by the way, but let's assume. Okay, let's assume there is a node called T2 micro, node instance type T2 micro, and I specify here that node selector hardware T2 medium. So this particular pod will get created only inside node 2, because it is matching it because I specify hardware T2 median. So it will get created inside this node only. Okay, so this is how I do the selector. Okay.
Yes.
Let's see one small demo of okay, let's see this label, how labeling is working. So I'm just adding this. Okay, this part I'm adding into my existing file. Let's create a new file. I'll do a cp or 1.yml or 3.yml, I'll call it. Okay, inside pod 3.yml, what I'll do, let's see, the restart policy not required. So here I'm okay, not here. I have to add some labels. Let's add labels here. So it's written here after metadata in parallel to name. Okay. It is written labels. Let's copy paste. Okay, so this is how I write. Just get rid of the extra spaces. Okay, always recommended, because if you don't, then you will get errors. I do a delete to make sure there are no spaces. sorry, this has to be in parallel. No spaces after it. No spaces after it. Oh, this is having a lot of spaces. Okay. Spaces. Okay, now it looks fine. Okay, so I'll save it. Okay, let's create this pod again. So how will I do it? I've just changed something to my YML file. Like I've created a new manifest file. So what is the command I do? I'll do kubectl apply -f name of the manifest file. Okay, so this will create a test pod as per the name. If I do kubectl get pods, it is showing me test pod is created and it's running. So there is a command to check. Okay, let's do -o wide as well, just to see everything in detail. Okay, so automatically it got created in node 2. Okay, now if I want to explicitly see the labels, okay, so the command is kubectl get pods -hyphen show labels. Okay, so see, this is giving you labels as well. So my multi-container pod is not having any labels, but my test pod is having 2 labels. Okay, so this is good for searching point of view as well. Okay, for example, you have uh, you have multiple pods. Okay, let's like in a EC2 instance, you have 10 pods. Okay, you have 5 pods which is having class is equal to pods, like environment is development, for example. Okay, so I can filter out from here like how many of my pods are from development environment. Okay, that I can filter out. Okay, so this is good for searching point of view, for search point of view. So yeah, and I told you, right, whatever commands that you're firing, we can either do it using your uh, in your manifest file. Okay, either you can do it from normal commands as well. Okay, normal from kubectl commands also you can create labels. Okay, so first way we saw that in our manifest file only we added some labels. Okay, but we can also create it from the command line. Instead of writing in the manifest file, we can write it in a command also. So let's say we want to label this container, this pod. Okay, let's label this pod because it is not having any pods right now. Okay, so we can label this pod as well. So you can do kubectl pods kubectl label pods, label pods, name of the pod. What is the name of the pod? Multi-container pod. Multi-container pod. And what is the label I want to give? Let's here give it environment is equal to production. Okay, so this is pod multi-container pod labeled. Okay, now if I see the labels with the show labels command, you see this is having a label called environment production. It got created just now. Okay, okay, got it.
Yeah. Yeah, correct.
Now, how this label, how we use it? Okay, let's say if we want to get the pods with environment name is equal to development. Okay, so what we'll do? kubectl get pods hyphen L. I'll write hyphen L means label. Okay,
Yeah.
label what? Environment is equal to development itself. So see, it is giving me only test pod.
Mm-hmm.
Okay, this is use of filtering. For example, right now we
Okay.
have two pods only, right? You can have 1,000
Yeah.
pods, and you want to list all the development related pods where you are doing development related activity. So you can
Uh-huh.
just label them and filter it accordingly. Similarly, you
Okay.
can, if I write production, I'll get the first pod, the multi-container pod.
Right.
Okay, so see, you have
Yeah.
we got multi-container pod. Okay, so this was about labels.
Mm-hmm.
Okay, so you can add, keep on adding many things. So whatever we discussed about the ports, let's say this I'm adding. Okay, I'm exposing this port, port 80 for this particular container. Okay, so I can specify that as well in my pod. Okay, so let's hyphen lstr. So I can create. Okay, let's edit in pod one only. Okay, pod one dot yml. Okay, start policy don't care. After that, we can just add here this port, like which port of this content of this container I want to expose. Just be careful with the indentation. Okay, I don't have any spaces after that. I don't have any spaces after that. Okay, what else we saw? Let's add all the things here. For environment variables also let's add. Let's copy it for you. Shit, sorry. They have to be aligned. I'll remove this. I just want to make sure there are no extra spaces. No spaces, no spaces, no spaces. Okay, let's rename this pod because test pod we already have. Let's call it uh, let's call it Saturday pod. Okay, so looks fine. So we have just read pod1.xml so we can create, we can do kubectl apply -f pod1 dot. Okay, so it says Saturday pods got created. Now if I do get pod or kubectl get pod. Okay, I see Saturday pod as well created. If I do -o wide, okay, so it says in more detail. Just a second.
Hello?
Mm-hmm.
You did. I thought you got stuck.
No, no, no. I got a ping. Just give me a second.
Yeah.
Okay. Sorry. So yeah, what was our this particular file? Yeah, we added a few changes there. We added a port and then we added environment variables. Okay, labels we already seen how that label is working. So yeah, now let's get inside the pod. So how to get inside the pod? To get inside the pod, command is kubectl. So all the commands are starting with kubectl only. Okay, kubectl exec -it. Okay, name of the pod. In which pod I want to enter? I want to enter Saturday pod. Okay, then hyphen hyphen. Okay, then /bin/bash. Okay, so you are inside Saturday pod now. You see, from this thing, it got changed into Saturday pod. Okay, so now in my environment variable, what do I define? I've defined my name is equal to Puneet. So just do echo. Let's see if environment variables are set up or not. Echo dollar my name. Yeah, see, environment variable has been set up. And this pod is like a normal this is like a normal virtual machine kind of thing, right? It is, I mean, inside my container. You see, everything is there here.
Okay, okay, yeah.
Okay. So we saw a couple of things. Mm, so there's a command to check. Let's exit from here first. So there's a command to check all the pods running inside all the containers. Okay. So the command is kubectl get all -a. Okay. You see all the pods now it's showing inside, running in my containers. Sorry, in my EC2 instance. So you see namespace. I told you the concept of namespace, right? So this kubectl get all a gives you detail of all the pods that are running inside a EC2 instance. So there are some pods that you cannot see. Like you cannot see means they are created in different namespace. If I do kubectl get nodes, oh sorry, if I do kubectl get pods, so that will give you pods located in default namespace only. And who is creating in the default namespace? It's you. Okay, so see, in the namespace you see default. Okay, on all these pods are which you have created. Okay, but there is a namespace which is Kubernetes namespace. Okay, that namespace is called kube system. Okay, here all those important files are located, like all those pods, like they have internally they are also running pods only. Okay, all the like all the components that you have installed, those are running in the pods only internally, but those pods are in kube systems namespace. Okay, they're in the kube systems namespace. See what are the pods: etcd, API server, control manager, kube proxy, kube scheduler, the VNet, the networking the networking thing that we installed. You see, everything is being run in a pod only, but these pods are located in kube system workspace. And the pods which we are creating, we have not specified a namespace while creating a pod, right? So by default, they are getting created in default namespace. Okay.
Yes. And these cube systems are the master bot system. Master.
Yeah. We are doing everything on the master only. Okay. All the
Yeah.
managing part we are doing in the master. We have not done any command on the nodes except on the installation. We have not done anything on the node.
Okay.
Okay. So there are many other concepts. So maybe we'll see tomorrow what are the other concepts. Replication, like other objects, I mean.
Yeah.
So today we just saw pod. Okay, pod is one of the object. So we have multiple objects: replication controller, replication controller, replica set, deployment object, networking, when network objects as well. We have many. So there is a long list. Okay, there is a long list.
Okay.
So let's go through them tomorrow maybe.
Okay. Sure.
Okay, because if I tell you a lot of things, it will be very difficult to digest today. So, but this
Yeah.
was the basics. Okay, whatever till now we have covered till today, this was the basics. Till here, if you are appearing for any interview or these things, if you tell them, okay, I have worked on basics, then that is fine. Okay, apart from that,
Okay.
there are some other concepts: replica set control, replication controller. Those things are important. Obviously, the Kubernetes is important,
Yeah.
but that will go into a lot of detail. Kubernetes, lot of detail. But yeah, this
Okay.
whatever we have covered in the last 2 3 sessions about Kubernetes, that is enough for you to start learning advanced concepts.
Right.
Okay, now you know the concepts.
Oh,
What is pod? How to manage all the pods? How to see all the logs? How to create a manifest file? What are labels, selectors, and all those things you have seen, namespaces. Okay,
okay. Sure.
now we'll see all the objects. We'll see what are different types of objects. So tomorrow will be the last session on Kubernetes because we'll not go into a lot of detail. So all the objects I'll tell in a basic, like
Okay.
basic stuff of all the objects I'll tell. Okay.
All right. Thanks. Thank you very much.
Okay. Okay. Then let's connect tomorrow.
Yeah.
I'll
Thank you.
share this document with you, and
Yeah.
also I'll manage all the steps. Okay. I'll write that steps in the document only.
Okay. Thank you
Okay.
very much.
Okay. Thanks a lot. Thank you. Bye.
Bye.
Have a nice day. Bye.